The Pythagorean Theorem. In any right triangle, the sum of the squares of the lengths of the legs are equal to the square of the length of the hypotenuse. So c squared equals a squared plus b squared. So in this problem right here, the hypotenuse is the c, so we're looking for it. And then I usually use the shortest leg for the a, although it would not matter if you swap those, and the medium size measure for the b. So c squared equals 5 squared, which is 25. Be careful, that does not mean 5 times 2, it means 5 times 5. And then 12 squared is 144. So c squared equals 25 plus 144, which is 169. Now, to get the c alone, we have to get rid of the square, and the opposite operation would be the square root. And since we're talking about the length of a measure, we're not going to consider the negative answer, just the positive one. So c is going to equal 13. And this 13 right here would be considered, or this triangle right here would be considered a Pythagorean triple, because 5, 12, and 13 are all integers. Okay, on this one right here, it would not be considered a Pythagorean triple because we're talking about decimals already. So the c squared, the hypotenuse points at the c squared, so that's 2.9 squared equals the a squared plus the 2.1 squared. Okay, let's find 2.9 squared, which is 8.41, equals a squared plus 2.1 squared, which is 4.41. All right, if I'm ever looking for a leg, I end up having to subtract. If I'm ever looking for the hypotenuse, it's just going to be an adding problem. So when I say subtract, this is what I mean. Let's subtract 4.41 from both sides. So I'm left with a squared equals 4. And then take the square root of both sides. And a will equal the square root of 4, which it would be positive or negative 2, but we're only using the positive 2 because you can't have a negative length.